Okay. Before we get started on new stuff, any questions or concerns with the stuff that we've covered so far? Hawks going okay with the homework and whatnot?
This past one, I think it was the data one where you could like click there was like 3 options.
Yeah.
That one, for some reason, was so hard. And it was not the first two. It was the ordinal ratio, like
because so when you're looking at those, it's because technically it's like a pyramid.
Yeah.
It could be all of them.
Yes.
So it wanted the highest level.
Like the one before it was like almost the same exact question.
Yeah.
But then I was like, oh.
Yeah, it's little differences. It's like that's why I said at the beginning, the hardest part of this a lot of times isn't going to be the math, it's the English and how you read it.
Yeah.
So it's very little changes can make a difference, unfortunately. Yes, but that typically is the hardest actual section in chapter 2 is those. And a lot of it's like I said, because it's pyramid. So like a ratio one is interval. It is ordinal. It's like because you can put it in order, you can subtract it, but you also could do that division step so that basically exactly. So
it was so annoying, which because the thing is it would be like, oh my god, there were things that would be like there would be continuous aspects to something. Like you would ask like IQ score. Like technically something could be now I understood it couldn't, but something could be like 1.7.
Yeah.
Like it could be a 0.7. But then it's like, no, that was distinct. And it was so frustrating going.
Yeah, so it's like you have to think about it like a lot of times you could do like the halves and stuff like that, and it works. But like I said, with like shoe sizes, like you can have a 3.5 shoe size.
Yeah.
But those are discrete because you can't have anything else. So it's like you have to and that's why if you remember one of the examples I brought in class, like there is a debate if money is continuous or not.
That was one of the things too.
Yeah, it's like, and I view it as continuous because like but technically it's not because you can only go down to a cent. However, when you're dealing with interest and computers and stuff like that, we can have things that are less than that and still build up. So it's like, that's why I say it's continuous, but there's people that argue that money is discrete. So
It really only down to discrete and continuous. It only becomes continuous with like the dollar. I mean, most countries nowadays have a dollar type system.
Yeah.
Where it's a point system, it's a
Yeah.
point-based system. But older currencies were like they had different types of coins for what it was.
right.
I mean, now in the US and in most countries, a $1.7 would be $1.70.
Yeah.
Back in the day, that could be like £1 and like 4 shillings.
Yeah, they didn't have actual like the Greeks actually didn't have decimals at all. Like they didn't have fractions of things. Everything, if you broke it down, if you wanted thirds, you had 3 pieces. They were just smaller. So when they were actually figuring out like pi and stuff like that, they only got it to 3 because they didn't understand you could go 3.1 or 3.14 and those type of things. And even in the Roman numeral system, they didn't have decimals. So that was the thing. When you're looking at money, you had those different pieces. So yeah, there's a lot of little things that are tough. It'll be very similar to that, except I think I'm actually going to pick specific questions. So I will try to pick the ones that aren't like insanely confusing. But yeah, it'll be similar to that because I'm going to do it right on Hawks. You're going to literally sit in front of the computer and do your test right on Hawks in class. So there'll be some very similar style questions to what you're seeing in the homework. So I'm going to try to have a review test put up on Hawks in the next like week or so. So you'll have a little bit of time to actually play with the review test, see if you like practice and stuff like that before you actually take the real one. Yeah.
Didn't the Greeks invent geometry? Or was that one of those things
No, they did.
Yeah, they
Euclid.
That's insane that they invented geometry and didn't have a decimal system.
Because you didn't need it. Because in geometry, like when you're doing proofs and stuff in geometry, everything is based on an unknown. So you don't need numbers at all to actually do those type of calculations. Correct. And that's why Pythagoras actually did mostly Pythagoras triples when he did the Pythagorean theorem. It was very straightforward things, which he didn't actually invent either. But that's a whole other conversation. All right, let's get on to data and graphs. So this chapter 3 is looking at visualizing data. So this is actually one of those things that most times, this is exactly what you see. You see a graph. So I'm actually going to steal the first graph they have in the book because it's actually kind of cool. So we always look at graphs and data as like numbers and like, okay, this is a pie chart or a bar chart or things like that. However, graphs can be, and visualizations can be anything. So this is not done on a computer. This is actually a hand-drawn graph. This graph represents Napoleon's march to Moscow. The size of the bar represents how many troops he had. So if you know anything about history, invading Russia is horrible. You never try to invade Russia. You always lose. Every army that's ever tried to invade Russia, at least from Europe, has lost. And this shows it. Like he left with, what did they say, 100,000 something troops? 425,000 troops he left with. He came home with 10,000. So you can see on the graph, like that representation. The brown line is where he's marching out. The black line is marching back. So this visualization, they say a picture's worth 1,000 words. And that's really what these type of things do. A graph is a picture. It gives you a very big overview of all that information and allows you to start looking for patterns and looking for things that you might not necessarily see in a list of numbers. Like I could easily list out the dates and his troop sizes and everything else, but looking at this and looking at that long list, you're going to get a lot more information from the graph. Okay, so visualizations are really important with those type of things. So we're going to look at a few of them to start with. First thing that we need to do is like, how do we actually create these graphs? So the first things we're going to look at is frequency distributions. So whenever you're starting to create a graph or looking at data, we somehow have to organize that data in some kind of way. And one of the most basic ways is a frequency distribution. This is just a technique that organizes data into classes and provides it in a tabular list. It's as simple as it gets. So we can have more complicated frequency distributions like this, where it's got a bunch of information. Or we can have a more simple frequency distribution that just has a single question and a single set of counts. So these are both frequency distributions. All right. It just depends on what you're looking at and the types of data and stuff that you're formulating. Honestly, if you've ever done an Excel spreadsheet, most of the times you probably did a frequency distribution because that's really what most people put in an Excel sheet. You're listing things and a list of data next to it. Okay. So the first table is populations and states from 2010 to 2016. We're looking at changes in populations. And remember, we only have census data in 2010, 2020, so on. So we don't have census data in 2020 or 2016. So that is an estimate of it. I get a kick out of the fact that they actually stopped right before they got to Connecticut. We actually grew by 0.2% from 2010 to 2016. And if you look at it, that's a lot lower than some of the other states. So while we're still gaining population, we're not gaining it as fast as other states are. Therefore, we're losing influence. Yes.
So each of those states, at least, show pretty high growth, especially Colorado.
Yeah.
But we also have only like moderately higher birth rates than Europe does.
Yep.
So is it immigration that comes down to as with?
Yeah, some of it is immigration. We do have that. We still do have a population growth. We're living longer. So when you have, so the replacement rate means you should have at least 2 kids per family. And that works. What happens though is since we're living longer, the death rate has gone down, which is also what's helping us increase our population. So, and we haven't gotten to the point where we have a very old population, like say Japan has, where they don't have that younger generation in the between that are having the kids that are outpacing the death rate. We still are outpacing our death rate in the United States. That's why we're still increasing that place. But immigration does hold a part in it as well. We do still have a healthy immigration to the United States, not including all the other illegals and stuff like that, but actually like actual immigration, we do still have a really healthy immigration policies or immigration rate. So you can see those numbers there actually, and if you, we will at probably that next class, I might maybe next class, maybe next week, I will get you set up with Rugio. Probably, actually, it might be after the first test because we don't really need it yet. But in Rugio, that has all this actually, all these data charts all there. So this is actually the table where that came from. And when you list it, Connecticut is the 4th lowest population growth in it. They're 0.1%. 3 states are actually lost population. And the Colorado was not the highest. District of Columbia technically was, although North Dakota was the highest when given an actual state was North Dakota. Was the highest growth rate. But when you look at it, North Dakota didn't grow by a ton, but they were very low population. So therefore that increase was a higher percent increase. Okay. So like Texas, actually, out of all the states, Texas actually had the highest population growth of just over 2 million people, almost 3 million people. All right, typically, frequency, so we remember we have 2 types of data, right? We have, what are the 2 types of data? Nope, the Q's.
Oh, quantitative and qualitative.
Right, quantitative and qualitative. So these 2 graphs, or these 2 frequency distributions are, well, this one's qualitative data completely. This one, the way it's written is qualitative data. However, you could easily do calculations on this would make it quantitative. But this one you can't. Like there's no way to say what excellent is or to do calculations and stuff like that on it. So this one is purely qualitative data. So you can use frequency distributions for both types of data. I wanted a graph for that one. Then they're not going to give me a graph. Why would they? This is so we're going to start looking at graphs. And they didn't give me one for that data, which is annoying. What kind of graph is this? You're making life hard. Yes. This is a bar graph. Very good. You were thinking way too hard about this one. This is a bar graph. So it is not the same data, but we can easily actually. Oh, actually, it is. It's this data point. So which one of these 2 would you rather look at? The bar graph or the table? Why? Okay. We like pictures. Okay. We also, most people actually don't like numbers. So if we can eliminate numbers, life makes easy. What's another difference between these 2 that you notice, except for the fact that one's a picture and one's a table? Yeah.
shows the percentage of frequency distribution.
Correct. So this one's got a percentage in it where this one did not. So we call those relative frequency distributions. So here is not that one. This is the relative frequency distribution. So it's called a relative frequency distribution because they relate to each other. Okay, so you're adding them all up and then dividing by the total or the number you have in each one to get a percentage of that. So looking at these two tables here, which one would you rather see?
I personally would probably prefer the percentage.
Why?
Just because sometimes you have to like conceptualize, you can think of like a whole group and then like this amount is very serious, whatever, versus like, to me, the 700 kind of just seems like
Rick, the numbers are a little bit smaller.
Okay. Smaller numbers are nice. Everybody here knows what a percent is, right? What's a percent? Okay. What's the whole typically represent? 100. Right. So we have the ability to look at it and we can conceptualize that number easily. All right. We know what the whole is. We know what 100 is. Like, okay, that's a big part of it. It's like we know anything over 50, if it's going to be over half. It's like we can conceptualize that very easily in our brains. So, like when you're looking at the 700, it's like, okay, in relation to what? Like, I can't really conceptualize. Okay, yes, it's bigger than 325, but then I have to start doing calculations in my head. Is it more than double it? Is it half? Like, we'd be able to do those calculations. Then we have to start thinking about things to really be able to visualize, like, is it way different than something else? So by putting in a percentages, that's something that we all understand now. Well, we understand it because you've learned it at some point in the past. But it gives us that ability to visualize things. Again, almost putting it into a picture in our brain and like, this is how it works. All right. So percentages are nice. And they are, because we know they're all based on 100, even if we have a drastically set of numbers, like in this case, these are not even, it doesn't even add up to like 1,000. It's like, it's a random number of it. By putting in percents, we put it all to a single number, which is that 100. It also allows us to compare different types of data. So we can look at like that percentage, and even if we don't talk to the same number of people next year, the percentage would change. We can figure that piece out. Where if we had it at 700 and next year, it was 650, but I only looked at 1,000 people, so now it's technically 65%. You would, like, if it was 700 and 650, you'd think, oh, it went down. But percent-wise, it might have gone up, depending on how many people you were looking at. Does that make sense? So it's like, that's why the percentages are very nice in that respect. Most of it, now, if I looked at the numbers, would the bar chart have changed if I put numbers, the actual numbers there instead of the percentages? Would it have changed the look of the bar graph? No, it would have been the same. The numbers on the bottom might have been a little bit differently, but they would have been the same length. So that's one of the nice things about doing it as a bar chart, is because it kind of forces that visualization on you. So even if it's not in percentages, you can still visualize that problem. However, now let's look at this. Okay, we're gonna turn this sideways. For any OCD people, I think it's straight up and down. It might not be though. But I'm gonna cut. And we're gonna look at just that. Are these two graphs doing the same set of data? Yeah. Are these two graphs the exact same set of data? No. I just cut and pasted. Okay. But does it change the data? So I literally just basically, actually, maybe you couldn't, because, oh, that's probably right. You probably can't see when I Oh, yeah, that's right. Yeah, you can't see when I actually cut things. So I literally cut it from the actual graph.
On the screen there, it's putting off the not sure, so it makes it look like it's just like this tiny little.
Correct. So when we're looking at, so this is one of those things when you're looking at visualizations. If I cut and don't start off at the 0, can that change how the bars look? Yes. So let's see if I can find the graph. All right, let's look at this graph. Okay, what do you get from this graph?
That there are, even with Republicans and independents put together, there's more Democrats who agree with the court than either of them.
Okay, good. Anything else we get from the graph? Yeah.
Interesting amount of Republicans and independents.
All right, so they're equal. Okay. How many times higher are the Democrats than the Republicans and independents? 3 times. Okay. So this graph, anybody know who Terry Schiavo is? So it was a when did it actually happen? Come to think about it. It was a long time ago. 2005 it happened. So Terry Schiavo was a woman in Florida, and she had a feeding tube that was feeding her. She was basically brain dead. And there was a whole big legal battle between her family and it was her husband. And one wanted to remove the tube, one didn't. And they went all the way to the Supreme Court, or the Supreme Court in Florida, that ended up ruling that they could remove the feeding tube from her and allowing her to die. This is the breakdown of, based on political party, who agreed with this. As you can think, in any type of situation like this, it becomes quite political. However, I want you to now look at the graph. Now what do we notice about the graph?
Marginal difference, really.
Doesn't start at 0. It starts at 50. Okay. So if we look at the this graph, which shows the exact same data, actually, hold on, let's go this way, and then I can do this. There we go. There we go. That's the same data. Okay. In this case, remember we said, what was it, Democrats were 3 times as likely to support the current case than independents and Republicans? It's actually only about 8%. Or actually, no, 6% difference between the 3 parties. And all 3 of them agreed with the decision. Okay, all of them are above 50%. So you can start to look at how these are both correct graphs. These are both bar graphs, both showing the exact same data. However, by displaying it differently, you can show a very different viewpoint on what happens. And actually, Can anybody read the very top of that graph? It says right under where it says results by party. What's the margin of error? Okay, what's the difference between Democrats and Republicans?
8%.
You said like 6%, right?
Actually, you're right. I think it is 8%. Sorry, I subtracted. It is 8%. I said 8 first, then I said 6. It was 8. So if the margin of error is 7% and it was opposite of that, there might be only a 1% difference between those two. If it's at the extreme end of it. Okay. So in essence, they're all basically the same. All right. But using graphs, we can drastically affect opinions. So that's one of those things where if we looked at the actual numbers for it, if I had just said Democrats 62%, Republicans 54%, Independents 54%, and just wrote the numbers down, there's no way to manipulate your view, right? You see the actual number, it's right there. Okay, and then it's just looking at that percentage and making that visual representation in your head. By putting it into a picture, putting it into that bar graph, now not only do I have the numbers weren't wrong, the numbers are still accurate. However, because of people's aversion to numbers, they're going to look at this graph like that. They're going to ignore the numbers on the side. They're going to look at just the visual. And that gives them a different view by looking at a picture. Do you understand, see how these things happen? Okay. So that's why one of the things I claim all the time is statistics is the one math you can lie with. Is because you can, by showing data in different ways, you can show your viewpoint in a favorable light or a negative light, the other person's viewpoint in a negative light. It's not wrong. It's lying with numbers. It's just a matter of what their perception is afterwards. So, okay. Both of these are bar graphs. This one's a deceptive bar graph because it doesn't start at 0. But there is no rule that you have to start at 0 when you create a bar graph. It's proper, but there's no rule on it. When you create bar graphs, these are the typical ways that you should do them. I'm putting this here not so you can write it all down. I'm putting it here so this way I can actually just read through it and you can see it later. They can be horizontally or vertical. They should be labeled on the bottoms and the sides. They should have both those information there. And it should give you enough description to understand what they are. Categories, if the categories have some order, they should maintain that order. So if you're looking at years, don't just jumble up the years, put them in order. However, again, these are guidelines. These are not absolute facts. All right, these are not rules that you have to follow. These are guidelines. So you should kind of maintain some kind of order in them. States, you do not have to necessarily put them in alphabetical order. That's not something that has to be in that order. That goes back to that concept of what type of data is it? Is it nominal? Is it ordinal? If it's ordinal, it should be that kind of order. If it's nominal, it doesn't really make much difference how you put them in that. Any type of other category should be listed at the bottom or on the far right at the end. It should not be in the middle of the data pieces. Okay. Even if you're putting it in terms of like order of percentage and stuff like that, the other one should always be at the end. It should not be in the middle of the data. So here's another. So if I'm a you're the boss, and I'm doing a performance assessment of my salespeople, and I want to fire Susan. Which graph should I use? The one on the right. Susan's way lower. Gives me justification to fire her. In reality, she's like what, 20,000 below, so it's not a drastic difference. But if I want to get rid of somebody, Susan's getting cut in this respect. And I could show that graph there as justification for it. If I was Susan, I'd be showing the graph on the left and going, look, we're all basically the same. So, same kind of concept. Next one. This is a special type of bar graph. I'm not expecting you to remember the name of this one. This is known as a Pareto graph. And to be fair, I didn't know there was a name for it either until I saw it in the book. A Pareto graph is a bar graph, but it is put in order of descending order of frequency. So this is what a Pareto graph looks like. We've seen them. Like that's a Pareto graph. So it's a graph that has the data broken down in order. So it's a nice descending type graph. All right. So looking at, actually, I'm gonna shrink it a little bit so that the words are not as totally spread out as possible. All right. What impressions do you get from this graph?
We don't even have like 1.2 billion people. 'Cause
You're correct.
Yeah.
But India also doesn't have just over 2 billion people.
Oh yeah, that's right. I didn't
So-
look at that.
Okay, so that is something you want to keep in mind. Okay. What else do we get from this graph?
Oh, okay.
Pictures are worth 1,000 words. I think I got 2. Yes. Okay. Yeah. Okay. Yeah. Anybody else? Somebody different. What do you notice? There is absolutely no real wrong answer in this question. Okay, so don't I have to make it. There's no wrong answers. Yes.
Does it really show like a time frame? So like, could these be like repeated people? Like, is that why India might be so high?
Yeah. So in this case, it's all the attendance in 2014. So I'm going to go off on a limb and go. This is basically ticket sales for the movies in 2014. Yes, it's all the sales for that year. So, yeah.
It also shows the frequency because India has what, like a billion people?
Yeah, just over a billion, yeah.
Something like that. So that is everyone going twice in a year.
Yep.
In the United States, we only have like 333 million, meaning people are going
3 or 4 times.
3 or 4 times.
Mhm.
So there's just it's also a radical difference in frequency. It demonstrates the frequency. Because
All right, so this is where looking at graphs and looking at data and how they're represented can be different. So obviously a country with a higher population should be higher on the list. That would make sense. So countries like India and China, which has over 1 billion people, should be higher on that list than other countries. So if you're looking at this graph, the United States is actually the outlier in this respect. Because our increase is way higher than our population would be. Okay. So that's why now if you're a movie exec these are your three biggest markets. They tend to focus on the United States more than they do on India, and to a lesser extent, they actually do focus more on China now. But because we attend movies a lot more often, right? We really take in that atmosphere. The other thing is in India, they have their own. They have Bollywood. That is their cinema. So Western movies don't really do as well in India as movies that were made in India. So that's where our movie execs don't really look at India as a massive market in terms of cinema attendance, even though they go to the movies a lot. Like, if you know anything about India, like India and China in their respect, they have their very poor areas and then they have their richer areas. Richer areas are very much like the United States. They're going to the movies a lot, where majority of the population is not. So same thing with China. That's why China is so low, because they have a lot more rural populations that don't have those cinemas and stuff like that in there. So, all right. But that's a peritograph. We just had the Olympics. This is the Winter Olympics, but we just had the Olympics. I like the Olympics. They're fun. Here's another wonderful bar graph. This is a graph easy to read. What are some general assumptions that you can get out of this graph? Yeah.
Russia is very competitive.
Yeah. This actually happened to be in Sochi. This was actually in Russia. Typically, the host country does better in the Olympics than they would otherwise. So yeah, this was when they were in Sochi. So they actually were in Russia in 2014. They do. The number one Winter Olympic country is actually Norway in most respects. In this respect, Russia did better though. Yeah.
Top three countries are all Arctic countries.
Yep. Which would make sense for Winter Olympics. Population-wise, we have a lot more population than these countries do, and yet they're at performance in the Winter Olympics. So, we have this graph, and then we have this graph. Which one's easier to read? Why? Mm-hmm. Yeah. What type of graph is this? Huh? It is a bar graph. But the last one was a bar graph too. What makes this one special? What do we do with the metals? So what word would we use to do that? We put them on top of each other. We stack them. This is a stacked bar graph. Sometimes math makes sense. This is a stacked bar graph. So the data shown on both these graphs is identical information, identical data. This is just easier to read. However, if we were looking at just like gold medals or silver medals, things like that, the other graph would give us that better information that we could easily look at that. This one's going to look at that total, and then we'd have to figure out, okay, where's the total come in? This is ordered by the number of gold medals. But as you see, like total medals, we actually had more than Norway and Canada did, because we had more bronzes than they had in the gold tournament. All right. What's the other type of graph we have? What's another type of graph we can make? It's everybody's favorite dessert. Pie. Pie graphs. Pie charts. Unfortunately, pie graphs and pie charts you can't eat. I should have found a pie chart on the favorite types of pie, because I think that would have been kind of funny. So a pie chart is a graph used to display categorical data. The vast majority of pie charts are based on qualitative data, not quantitative. And they always have to be done in percentages. Okay. A pie chart always has to be done in percentages. All right. So here is a bar chart and a pie chart showing the exact same thing. So when you're looking at how it's done, it's qualitative. So because you're not doing those calculations and stuff on it. So which one is easier to read? Okay. So because again, when we're looking at that type of calculations, it makes more sense to us. I'm trying to find. Let's see if I can find it for 2023. I just want a pie chart. I'm trying to find a more recent one, but I want it in a pie chart, and they give it to you in a million different other types of graphs. Nope, that's not the one I want. All right. What are some of the things you notice about this? While I'm looking for the graph that I really want.
More than half the budget is spent on like social services.
Okay. So, my other graph. Yeah, if we're looking at this, Social Security and Medicare makes up a large chunk of that budget. Those should be covered. So this is the income. So that's the spending. This is the income. So payroll taxes is your Social Security and Medicare, of which you pay half. Your employer also pays the exact same amount that you pay in addition to what you pay. So your Social Security and Medicare, I think it's like 6.25. It changes. I think it's like around 6%. So your employer also pays an additional 6%. So if you ever want to run your own business or you want to be self-employed, you have to pay the entire thing. So if you're self-employed and it's 6%, 6%, you'd have to pay the 12% to cover that, the Social Security and Medicare taxes. So things that people don't actually normally recognize. All right.
It's also crazy. I had to look it up. Total like taxes revenue for the United States is a little under 3 trillion, right? Or like it says right there. The total student debt in the United States is 1.74 trillion.
Yep.
About half.
Yep. I'm gonna try it. Okay, we'll use this one. All right. Just because I can't find a nice part. Nice. Yeah. Go ahead.
That'd be a dumb question. But what determines the percentage of taxes? Like how much?
The government decides it.
Is, or what they decide, or is it based on something?
No, it's not based off anything. They literally just decide how much they want to charge us. You would think it was based on something. You think, wait, hold on, you're spending this much money. I need to bring in this much money to cover it. Like that's what you would think. No. You would think, okay, $3.36 trillion I'm spending. The receipt should be $3.36 trillion, about the same, or maybe a little more. Yeah. That's what the debt is. The difference between those is what's added onto the deficit each year. So here, so this, I will share this. This is from the Congressional Budget Office. This is the actual official government website. So the stuff that I'm going to show you is literally exactly what the federal budget was in 2023. So this is how much money was spent. Okay, so we could figure out, actually, I'll figure it out real quick. So in the one we had just looked at, because 0.36 times 0.38. The Social Security taxes in 2015 were $1.27 trillion. How much is Social Security this year or last year? $1.3 trillion. So it's pretty similar. All right. That really hasn't changed much. The Medicare was 940 billion. Medicare has actually gone down in our budget. But you actually have to add Medicare and Medicaid, I believe, was combined. Yeah. So that would actually, that's gone up from our things. What was the other one on there? But here's the big one. So defense in 2015 was $537 billion. What was it last year? Yeah, $805 billion. So that's definitely gone up quite a bit. And if you add in the non-defense and the defense in there, the non-defense is not military spending, it's just other stuff. But here's the biggest one. In 2015, the interest on the debt was it 6%. Was $200 billion. Our interest last year was $659 billion. So that's almost triple. So more and more, and actually this year, as crazy as it's going to sound, the amount of interest on the debt actually cracked $1 trillion. So we're paying $1 trillion a year in interest on our national debt. Now, remember you're saying, well, okay, how did they come up with taxes? We spent $6.1 trillion last year. We only brought in $4.4 trillion.
I have a question.
So it's difference. Yeah.
Country not in debt.
No, every country's in debt. It's actually a function of our monetary system. We kind of have to be in debt. It's just the way that it works. Economically wise, if we were actually to eliminate our debt, it would actually cause more issues than it would solve. The problem, though, is you don't want to be in debt enough that it's actually becoming a hindrance to you doing other things. And that's where we're starting to get to that level in terms of if you're looking at the numbers here. So, yes.
Same concept as a credit card, but on a macro scale. You want to
Yeah.
always have a little bit of debt on the credit card so you can pay it off.
Yeah.
Improve your credit score, but you don't want to have too much that you can't pay it off.
Correct. Yeah, in essence. That's not a horrible thing. It's just in moderation. So, the $1.6 trillion this payroll taxes should match what Social Security, Medicare, and Medicaid is. And as you notice, it doesn't. That's why Social Security and stuff is in danger, because that payroll tax should cover this stuff here. That's what it should cover. It doesn't. Because they keep cutting that to make things life easier, because that gives you money immediately back on your paycheck without realizing that money needs to come from somewhere, because at some point we want to collect Social Security. So, yep, that's our budget. And it's one of those things that when you're thinking about, because the federal budget is so huge, when we're looking at like these large numbers, it doesn't really make sense to us, where pie charts and graphs kind of help us or understand and look at that stuff in a little bit better of a way. Yeah.
So you said that our taxes are based off of debt,
Should be. Should be. It's not.
but it's not. It's like you said, they just conjured up.
Yep. And then they cut it when they want to make you feel better. Because again, we like lower taxes. The less money coming out of our checks each week, the better. Like, it's that whole joke on I've seen the videos on TikTok when the kid opens their check for the first time. It's like, oh yes, I work 20 hours a week. I make 20. It's like I should have like $300, and their check is like $200 or $150. It's like, where's all my money? And it's all the deductions and stuff. Like, we like our money. We like being able to get our money. However, we also like getting stuff, and the balance has to be there. It's like, where does that money come from to pay the things? So, and looking at, like, there is no way for any of us to be able to understand what the trillions, like when you hear billions and trillions and stuff like that, you can't visualize those numbers because they're just so large that, like, when we're looking at our scale, we're talking like $1,000 is a lot of money to most of us. Like, if I was to give everybody here $1,000, you guys would be extremely happy. Okay, if I gave $1,000 to the U.S. government, it would already be gone. Like, before I literally handed to him, as I handed to him, was gone. That's how fast the money is spent on that level. So, like, trying to be able to visualize that information, like, just in our heads is very difficult. And that's where the graphs and stuff come into play. These aren't exactly pie charts because they don't go all the way around and they're not done in percentages, but it's almost like a circular bar graph in essence on this respect. But it does show that information in a way that we can start to visualize where the money's going and how it's spending. And with like this, that mandatory, that spending, that stuff that you have to spend out is a lot higher than that discretionary spending, which is what all Congress and everybody else and all politicians are fighting over. That's where they want the money to go. It's like, oh, I want this money to go here and that money to go here. And for the Department of Education and all those other programs and stuff like that, that's where that's going. So, okay. And know the U.S. government cannot just print $1 trillion bill and pay off things. It doesn't work that way. We learned that in COVID. It does not work that way. So, all right. Pie charts are great. However, sometimes too much of a good thing is a bad thing. This is a nice pie chart. Tells me the sales of 5 employees, really nice, easily drawn out, written out, stuff like that. This is also a pie chart. Completely correct. The data's right. too much of a good thing's a bad thing. Okay, it's just there's so much information. It's hard to be able to understand what's going on. This is a graph that would make much better sense in a bar graph or in a table of just data that you can look at, and not as a really messy pie chart. All right, so everything has its limitations when you're creating them. All right. Okay. I'm done. On Wednesday, we'll start talking about quantitative data. We'll start talking about quantitative data and actually being able to start doing calculations on it. Notice most of the data we talked about today, we did not do those calculations on. Yes,
Oh, 15 minutes.
I know.
Okay.
So it's what? No, I know, totally know you have 15 more minutes. Except the problem is if I start the next thing, I'm not finishing in 15 minutes. So starting it and stopping it directly in the middle isn't going to be is going to end up hurting you more than helping you. So we covered half of chapter 3. We did chapter 3 or 3.1 and 3.2, so you should be able to do the homework on those. We'll do 3.2, and actually we talked about 3.5 a little bit as well. We will do 3.3 and 3.4 on Wednesday.
I want to use it in taxes. Yeah.